Hi everyone, my name's Alex and welcome to an Engineer's Findings. So today's episode is not about this contraption here. Whatever it may be, you can leave a guess in the comments because this is something for an upcoming video. Rather, today's episode is another wristwatch machining modification type of deal. And it concerns this classic Omega Seamaster here that belongs to my good friend Christian, whom I went to college with. But come to think of it, I call him Mr. H for some obscure reason, and so I better stick with this to stay consistent. So the story behind this watch is Mr. H inherited this watch approximately 1 year ago from his late father, and this watch was given to his father in roughly 1968 by his wife to their wedding. And Mr. H tells me that his father, who had a very active lifestyle, by the way, I knew the guy, he did wear this watch every single day of his life, it seems, and he didn't even take it off for sleeping. So I guess you can see, aside of the collectible value that this watch has, the sentimental value that is attached to it for Mr. H is Pulp Fiction, Bruce Willis kind of deal. He didn't even ship this watch to me, he brought it to me personally because he was afraid it might get lost during shipping. So yeah, I have been very careful with it, believe me. So this watch is in perfect working order. The only problem with it is I believe this housing is particularly intended to be equipped with leather bracelets. I'm not sure if there are Omega bracelets out of metal available for this type of housing. But Mr. H would like to wear this with a metal bracelet because he cannot stand leather bracelets because they stick to the skin so much when you sweat. His father didn't care about this, it seems, but it's a difficult task to find a matching bracelet for that watch. So Mr. H wore this watch with a cheapo, flexible metal bracelet, but it broke apart quite soon. But after some watch time, he found this used Omega Seamaster metal bracelet here. It's quite worn, but it has the correct width to fit that housing. The only problem is the pieces at the end of the bracelet, they don't fit the housing very well, or at all. I'll show you in a second. And Mr. H asked me consequently if I could, if I know some source that could supply pieces that are matching, but you know, I'm not a watchmaker. Why do you ask me? Then he asked if I could modify these pieces or machine them, and I said, hey, I'm not a watchmaker. Yeah, long story short, he brought this watch to me and asked me to modify this. So hopefully these pieces will fit the watch, and he hopefully will be able to wear this with this bracelet. To the watchmakers, I apologize if this is sacrilege to do to an Omega metal bracelet to machine it, but yeah, it's what Mr. H asked me to do, so that's what we are going to take a look at in this video. And if you're interested in this sort of thing, join me, why not? So here's a close-up of that watch, and you can see by the scratches on the housing, the character which this watch has from the many days that Mr. H's father did wear it. So our concern is these connections that the bracelet has with the housing. And now the bracelet that Mr. H got is this used Omega Seamaster bracelet that has the correct width for these housing connections. However, you can see the shape of the connection piece, or the bracket, let me call it. I don't know the exact name of this piece. So the shape of it is completely different than what we need here. Now, let's see if we can machine, firstly, we have to take off these pieces and see if we can machine those to fit said shape here. But first of all, we have to somehow measure the shape of this pocket here, particularly the angle and the radius in relation to the pin that goes in here. So let's see what we can do about that. And then based on these dimensions, we can see if we can machine these pieces. However, to machine these pieces, that will be a work holding challenge, to say the least. So let's see what we can do about this. So how to come up with these dimensions in relation to the pin? Well, first of all, of course, we have to install the pin. I wonder how these pockets are machined into that housing. I believe they can only be machined by electric discharge machining it. Maybe some of you can fill in the blanks here? I don't know. And to come up with the dimensions, I propose to use some white powder and ingest it until I am so far detached from reality that I don't give a crap anymore. No, actually that's nothing to joke about. I'm sorry about that. This is Mold Maker's glue, or X70 glue as it's also called. X70 or 60, I'm not sure. Ooh, the stupid boy almost forgot the parting spray. So this is just some spray with wax, parting spray or mold release, whatever you want to call it. And then let's try to mold it without getting it close to the pin tips. And for a measurement reference, I would like to use this aluminum block here to form the cast piece with an additional back reference plane that we will use during measuring then. The smart guys among you will say, ah, Alex, you forgot that mold release on the aluminum block. Yes, sir, I did. Let's give that some time to harden. Usually it takes 5 minutes or so. And fill up that cavity. Hope that works. Yeah, worked out. I had to use a little force to break it off of the aluminum block. However, the mold release should work on the watch housing, hopefully. Let's see about that. Yes, that worked nicely. Don't worry, I'm not scratching. I'm being very gentle and just flaking off the excess glue. And now how to get the pin out of the molded piece. So I will use this 1.5mm collet in the D-bit grinder, because that lets me grunk down on the spring-loaded tube without a lot of danger of crushing it. Slips in the collet. Yo! Yeah, still slips. I need more clamping area. So let's take off some of that glue. Molded piece will be long enough even that way. Yeah, I guess I went too easy on the mold release on the pin. Ah, it broke. But I got both pieces and we can glue that together. And the pin's still alive. Super glue to the rescue. Yeah, sorry for being out of frame here, but I needed my senses. That looks okay. So here I'm trying to square up the ends so they are perpendicular to the hole as best as I can, freehanding it on the belt sander. Yeah, I didn't notice how shaky the camera was, sorry about that. And off to the Nikon profile projector. The rotating table is a nice accessory for the measuring task ahead. So let's set it up here. Our molded piece. Let's get it within the screen with the low magnification first. Focus it. Yep. And find the center and then go to 20 times magnification. And then adjust the top light mirror and the backlight. So that's nice. Okay, even though I'm being a bit chaotic here, first we want to adjust the rotating table so that our reference plane, so that's the bottom one here, is parallel with the screen grid. So that's what I'm not doing here. Come on, set it parallel to the screen grid. Yeah, thank you. Okay. Next, let's center up the part on one of the screen grid radii and set our 0 position there. So that's good. And first I'd like to measure the angle of the top edge. The bottom edge is still parallel. And to measure the top edge angle, I use the screen grid vernier. Set the screen grids parallel. And read the value. Something slipped on the screen grid. It's just slightly clamped to the screen. So I have to reset the origin again. Yep. And now let's measure the radius of the transition. And for that I'm moving the part to a fitting screen grid radius. And so I can firstly measure that way how large the radius is by reading the screen grid, and secondly I can determine the center of said radius relative to the hole in which our coordinate 0 is. So I believe it was a good call to make this cast here and take the dimensions off of the cast rather than using the calipers on the housing here relative to the pin, because as you can see from the dimensions, this transitional radius that we have on the housing is eccentric or offset with this dimension here from the actual hole location, which is kind of surprising to me, but yeah, it is what it is. And it's a good thing we caught this before we started machining. And the other thing I wanted to mention, so the housing obviously is this transitional radius is 2.5 millimeters, and let's machine the piece that will go in there a slight bit smaller than that to have a slight gap here. So let's say we make it 2.4 millimeters on the part. Now the part I mean, let me reset the focus. The part I mean is this one here, and let me try to disassemble this here on camera. So I ground this, I don't know if you call this a punch or not. It's a broken off piece of twist drill that I ground to a 1mm punch. Let me find that pin. There it is. So these pins are usually just wire that is slightly deformed on one end, and then they are press fit into that into the bracelet. So now we have to machine this shape into this part, and we have to register the machine coordinate system with that hole location here. That's difficult task number one, and we also have to clamp this part somehow in the machine without damaging it and with still providing enough clearance for the tool to machine these close features. So let's see how we can solve that problem. So off to the Mikron mill. Let's oil it first. Nice. Note to self. It's a good thing that I will do this on a not cleaned machine, because these itty bitty small parts, they will be very easy to find among the chips that are already on the machine. Nice work, Alex. Yeah. So first let's machine some clamping features or retaining features into this piece of aluminum here. And then let's see how we can mount that little part, mount and align that little part with the machine. But I'll get you closer in for that. Hold on. One of my oldest 3-flute end mills. I believe it's even a high-speed steel end mill. But it'll do fine for the job at hand. So first we have to machine a reference surface on top of this blank here. And what I'm doing here, traveling to the edges, is I'm using the halving function of the DRO, for lack of a better term, to set my coordinate 0 roughly in the center of the blank. Alright, so machining the top reference surface. And yes, I know my vertical spindle has developed a funny noise over the last months, but I haven't yet looked into it, other than I have no play, no radial play. So I guess I will wait until I'm in the middle of a time-critical job for this to worsen. So the step here, I'll explain that in a second. Still have some material protruding the top. Okay, taken care of. It's not deep enough for the part yet. Alright, so these two pockets here, they have a step, and that step now easily registers with a twist drill that I have in the drilled hole here. And what we want is the location of the drilled hole. So now we know in vertical and in X direction where the hole is. So that's fine. However, what is not fixed in this setup is the rotation of the piece. And I want to set the rotation in a way that this cylindrical feature of the part here, that I believe was intended to be perpendicular the axis of it should be perpendicular with the back plane of the watch, I believe. And I also want that with this piece now and with Mr. H's watch. So, because this sets the approach angle of that curved feature here. And I want this to be, well, sloping gently into the housing, not in a kinked fashion, but in a gentle transition. And I'm quite sure that setting this in such a way will take care of that. Now, I think we can fix that by placing such a cylindrical piece here. However, I want the cylindrical piece now to be horizontal as it lies on that cylindrical surface here. And we can check that with this little spirit level here. That is, yeah, you see the y-axis of my machine here is not perfectly level. However, the x-axis, which matters here, this one, is. So we can use this level here to check how that piece is oriented. Of course, I have to feel for the lowest spot here for this to be true, but you can see when I rest the cylinder here now on this surface and on this one, which would be nice for aligning the part, then you can see the drill pocket is too high. So let's machine the drill pocket a bit lower so that if I rest the cylinder piece on both parts, the watch piece will be aligned. That should work out. The only question is how much deeper shall we machine this? But I believe with the feeler gauge we should be able to find that without going back and forth many times machining it. So that's 0.8. No, that's too high. Let's go back. Let's go back 0.6 millimeter. Okay, 0.6 is too low. Let's go 0.65. No, 0.7. That's the middle. Let's try that. Okay, 0.7. Yeah, actually that looks really nice. Yeah. I have to find the low spot for this test, but 0.7, what is this? 0.7 and something. Let's machine it 0.7 and something deeper in order to be able to do this without the feeler gauge, this alignment. Yeah. No? Yeah, 0.7 and something. Let's do that. Let's try that once more. Yes, that should work. Okay, nice. So, before I reveal to you how I will fix that part now in that pocket, let's do the final machining step first. And let's use a woodroof cutter to machine some retention features into the bottom of this pit. So I mean a mill such as this one here. Give me a second to set this up. Now for the anchoring part of this setup here. For registering the hole, I'm going to be using this twist drill again. Put it this way around. And then I'll also put in one of the pins in here so that the bedding material has a chance to have a grip on the part. So with all that being said, here is my cylinder tool. For the bedding procedure, I'm going to be using a low temperature melting alloy. It's called woods metal or woods alloy. And just a second now. Oops, too much. Don't matter. And it melts at 80 degrees Celsius or 160 degrees Fahrenheit approximately. So there is no danger involved for any of the alloys. Even for my bare hand here, I don't even feel the heat in this part while I hold it. And now, that was, by the way, that bedding alloy was, by the way, mentioned by Dan Galbert in one of his recent videos. Please check it out. He also mentions a good source for that material. So, let's see about how that turned out. Now, these pocket features that we machined at the bottom should anchor the bedding material to the bottom so that it cannot be pulled out. And the pin that we have on the bottom side of the part should also anchor it in the material. So hopefully, fingers crossed, we can machine the radius now onto this part without it getting torn out of the setup. That's touching off the ball end mill on our reference plane to get our Z coordinate. So what I did in this first step was to use this ball end mill to radius interpolation mill this transitional feature of that part. Now this was the roughing step, the first one. I used a radius 2.6 millimeters and now we take it down to 2.4 millimeters. So we interpolation mill it arc in X and Z direction. Then the center position is the same. The roughing step was radius 2.6. Now let's take it down to 2.4. The finishing dimension, the tool diameter is 6 millimeter, and the maximum cut we go is 0.5, and the starting angle 90 degree and the end angle 180 degrees. And we want to go to the outside of the radius. And so let's go to the starting coordinate, go to 0, 0. And then we'll make our first cut, and the second one, third, fourth, fifth, and so on. So that looks okay. The twist drill is still pushed nicely against the step. So the part didn't move on us, even though we removed quite some material. And even though we don't need this transitional radius on the other side, which is the side that is towards the arm when you wear the watch, But I still want to complete that radius on the lower side, because I think it would be much nicer than if there is an edge here. So let's machine this also to the other side. Oh, that part came loose. Hold on. So during the last step, during the last increment of the roughing step, the part came a little loose, and let's see how loose. Yeah, I can move it. It's still anchored with the pin that is on the lower side of the part, but I don't trust that for the finishing, even if the finishing is just 200 microns on the radius. I think what I will do is to hold it down with a small screwdriver here and do the finish machining step. So let's see how that goes. Oh, sorry, the camera slipped. So that's how the part came out of the cast. And the cleanup usually is quite easy. Just have to spick it off. Yep. Yep. Let's rescue the pin. Yep. And now yeah, not too bad. Of course we have to file finish this because it's just an interpolation mill. There, the land here where we machined the inside, or the side that is towards the hand, this is a bit narrow, you could argue, but still I think it's way strong enough to share the spring-loaded pin before this breaks off. So I think we're good here. Now let me use the file to clean up this step here that remains from the old shape, and also let me use the file to file in this 9.5 degree roughly slope that we need here. I didn't even try to machine this in the bedding because you saw as it was, we tore it out from the bedding, and I wouldn't have dared to go any deeper. So we do that with the file, and let's see how that turns out. Time for the showdown. Did we make mistakes or will it fit? Alex, you know, the lucky ones are the dumb ones. Yeah, I'm okay with this. The angles look nice. The range of movement is good. So let's finish the surfaces. That blasting cabinet is made by Balduf in Germany. I'm really happy with it. Bought it in the used condition 2 years ago or so, and didn't ever disappoint me once. I'm using 220 grit glass bead media here in order to give this a satiny kind of textured surface look. Turned out okay, I think. But in order to not have the brass tarnish and to have the same color as the rest of the watch has, I'd like to put a thin layer of nickel onto these parts. But first let's clean them in the ultrasonic cleaner while I prepare the electrolyte. Rinse in distilled water and tie it to the holder that will then get attached to the negative pole. Yeah, it's negative even though it's a yellow wire. We need a bit more chaos. Take care that the parts are properly submerged, but don't touch the bottom. Yeah, that looks okay. And on the current, since these parts are so small, I only go with maybe 100 milliamps, maybe even less, for a quarter of an hour or so. That will completely suffice if in that case. I could watch this all day. So the satin finish even translated out to the nickel layer. That's nice. Important for that is also to have the parameters right when you're plating. If you have too much current for the size of the part, then the surface texture will get, yeah, iffy, for lack of a better term. Okay, assembly time. So what do you think, guys? I hope Mr. H will be able to live with that. Also Mr. H's father. I did my best.
Your best. Losers always whine about their best.
So I'll leave the bracelet long for Mr. H because he's kind of a bear and he can still adjust it for size. And I hope you found the one or the other thing in this video useful or interesting. And I appreciate your time, and I'll see you on the next one. Bye.